Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In free radical bromination, bromine radical is highly selective due to its high activation energy for H abstraction. It preferentially abstracts H from the most stable, highest substituted, carbon, 3 degrees greater than 2 degrees greater than 1 degree. Benzylic and allylic positions are also highly activated. We need to identify reactions where the major product is a secondary 2 degrees alkyl bromide. P. Cyclohexane, all 12 hydrogens are equivalent and all are secondary 2 degrees hydrogens. Each carbon in cyclohexane is bonded to 2 other carbons. Therefore, the only possible product is the 2 degrees bromide. Major product is equal to 2 degrees halide. Q. Methylcyclobutane. The ring carbons include one tertiary carbon bearing the methyl group and secondary carbons. The 3 degrees H is preferentially abstracted by Br due to selectivity of bromine. Major product is equal to 3 degrees bromide, bromination at tertiary carbon. R. Ethylbenzene, PHCH to CH3 benzylic position is the CH2, secondary benzylic carbon, 2 degrees benzylic. Bromine radical selectively abstracts from the benzylic position due to resonance stabilization of the benzylic radical. The benzylic carbon, CH2, is a secondary carbon attached to phenyl ring. Major product is equal to 2 degrees benzylic bromide, PHCH-BrCH3. S. To methylpentane, structure is CH3CH, CH3, CH to CH to CH3. It has 3 degrees carbon, C2 bearing to methyl ethyl groups. Bromine's selectivity strongly favors the 3 degrees position. Major product is equal to 3 degrees bromide. T. Decalin, bicyclo, 4.4.0, decane, to fused cyclohexane rings. The ring junction carbons are tertiary, each bonded to 3 other carbons. Br will preferentially abstract from these 3 degrees positions. Major product is equal to 3 degrees bromide. U. The structure shown appears to be a straight chain or slightly branched alkane, drawn as a zigzag with no branch shown clearly, appears to be in pentane or similar straight chain. In a straight chain alkane like in pentane, there are no 3 degrees carbons. The internal carbons are 2 degrees and terminal carbons are 1 degree. Bromine selectively abstracts from 2 degrees positions over 1 degree positions. Major product is equal to 2 degrees bromide. Thus, the reactions giving 2 degrees halide as major product are P, R and U. Options A, P, Q, R, S includes Q, 3 degrees product, and S, 3 degrees product, excludes U. Incorrect. Options B, P, R, U matches R. Analysis correct. Options C, P, R, S, T includes S and T, 3 degrees products, incorrect. Options D, P, Q, R, S, T includes Q, S, T, 3 degrees products, incorrect. Therefore, the correct answer is B. Therefore, the correct answer is option B.